Now let us look at some activities. Take a heavy rubber ball and keep that rubber ball in a glass tumbler which is filled with water, and look at the rubber ball from outside. What changes will you observe in size when you are observing the ball from the sides? Well, if you try to look at the rubber ball from the sides, we find that the rubber ball appears bigger in size than its actual size. Now take a beaker filled with water and place a pencil in the beaker in vertical position such that half of the pencil, a part of the pencil is inside the water and the remaining part of the pencil is in the air. And observe the pencil from the sides of the beaker. What will you observe? We find that the part of the pencil which is inside the beaker appears to be thicker, whereas the part of the pencil which is in the air appears to be normal in size or in thickness. Now, instead of placing the pencil vertically, place the pencil obliquely in the same beaker as you see in the figure. Now, when the pencil is placed obliquely, we find that the pencil appears to be bent at the boundary. As you can see in the diagram, the pencil appears to be bent at the boundary separating water and air, and the part of the pencil which is inside the beaker appears to be thicker with respect to the part of the pencil which is present in the air. Let us try to understand these activities. Now let us consider two different mediums. This is air and this region is water. Now what is a medium in physics? Any substance that carries a wave or a disturbance from one region to another region is called as a medium. So air is considered as one medium and water is considered as one medium. Now when a ray of light travels obliquely from air to water, so air is considered as one medium and water is considered as another medium. So when a ray of light travels obliquely from air to water, we find that when the ray of light hits the air-water interface and then enters water, we find that the ray of light bends. Okay, let's consider the opposite case. So the ray of light is traveling from air to water. Okay, so what has happened to the ray of light? The ray of light has bent. Now consider the reverse case. The ray of light travels obliquely from water. Okay, so this is the direction in which the ray of light is traveling. Now as soon as it reaches the water-air interface, now we find that the ray of light will bend. The ray of light bends. Similarly, let us take another case. In this case, we are considering two mediums, air and glass. The ray of light travels obliquely from air, and when it hits the air-glass interface, we find that the ray of light bends. Let's take the reverse scenario. The ray of light travels through glass. It hits the glass-air interface, and then the ray of light bends. So what happens when a ray of light travels obliquely from one transparent medium to another transparent medium? That's correct, the ray of light bends. And this change in the direction of ray of light when it travels from one transparent medium to another transparent medium is called as the refraction of light. Now why does the ray of light bend when it enters into another medium? This is because the velocity of light is different in different mediums. Here you can see in air the velocity of light is 3 into 10 raised to 8 meters per second. But the speed or the velocity of light in water is 2.26 into 10 raised to 8 meters per second. So when the ray of light is traveling through air, it is traveling straight. But as soon as it enters water, what is happening to its velocity? Its velocity changes. Therefore, it bends or it changes its direction. Similarly, When the ray of light is traveling through water, what is the speed? 2.26 into 10 raised to 8 meters per second. But as soon as it enters air, its velocity increases. It becomes 3 into 10 raised to 8 meters per second. So what happens when the ray of light moves from one medium to another medium? It changes its direction. Similarly, look at air and glass. If we consider air as a medium, what is the velocity of light in air? 3 into 10 raised to 8 meters per second. But as soon as it enters glass, see, its velocity changes. It travels with a speed of 2 into 10 raised to 8 meters per second. So the change in the direction of ray of light happens because the velocity of light is different in different medium. So what is meant by reflection of light? The change in the direction of ray of light when it travels from one transparent medium to another transparent medium is called as refraction of light. Now once again, let us take the example of the pencil as we have seen in the activity. When the pencil is placed obliquely in a beaker containing water, we find that the pencil appears to be bent at the region or at the boundary separating air and water. Now what happens is, when the pencil is kept obliquely in water, the rays of light, these are the rays of light which are starting from the pencil, okay, as soon as they reach the water air interface, what is happening? The rays of light are bending, okay. So a person will observe this particular pencil, but the line of sight of the pencil is along the straight direction, okay. We cannot see any object with our vision bent. Our line of sight is always in a straight line. So if we extend the rays backward, we find that this is the point where the two rays meet. So if we are drawing the pencil here, the pencil will appear to be bent at this particular region. And why is the pencil appearing to be bent? Because the rays of light are traveling from water to air. And when these rays are traveling from water to air, what is happening to the speed of light? The speed of light changes. Similarly, if we keep a coin in a beaker containing water, the rays of light are traveling through the coin. They hit the water air interface and then they travel in the air, and when they travel in the air, they change their direction. The reason is because their velocity changes. The velocity of light changes. Now if we extend these light rays backward in water, the rays of light meet at this point. So actually the coin is placed at this position, but to an observer the coin will appear at this position. And this has happened. Why? Because of refraction of light. Now look at the coin which is placed in a beaker filled with water. This is the actual position of the coin. But when we look at the coin from the region or from the medium which is present in the air, the coin appears to be raised up. Now what is happening in this case? The rays of light are starting from the coin, and the rays of light, they start from water and they reach the interface separating air and water. As soon as they enter into air, we find that the rays of light bend. And so these are the rays of light which are traveling from water and they are entering into the air. Now a person who is viewing the coin will always see the coin in a straight line path. So when the observer views the coin, this is the point where the rays of light are meeting, and therefore the coin appears to be in this position. So this is the actual position of the coin, and this is called as the apparent position of the coin. So the viewer is able to see not the actual coin but the apparent position of the coin. Let us try to understand the phenomenon of refraction of light with the help of an experiment. For this experiment, take a blank drawing paper. So suppose this is a blank drawing paper. We also need a rectangular glass slab. So take a glass slab and place it on the drawing paper and draw the outline of the glass slab. Remove the glass slab and name the glass slab as PQRS. Now draw an inclined line, straight line. This is an inclined straight line, and let it meet side PQ at point N. Now this ray of light which is traveling towards another optical medium. Why another optical medium? Because this medium is air. So this is another optical medium which is glass. So this ray of light which is traveling towards another optical medium, I will call this particular ray, that is ray AN, as the incident ray. Okay. Now fix two pins A and B on this particular inclined straight line. Place the glass slab once again on the outline. Stand on the other side of the glass slab and look out for the reflection of the two pin heads A and B from the other side of the glass slab. Fix two more pins C and D on the side SR of the glass slab such that the reflection of the pin heads A and B and pins C and D, all four, appear to be in a straight line. Remove the pins, remove the glass slab. Now join the inclined line CD in order to meet side SR at point M. Also join point M and N. So I'm going to join point M and N. Now, as I said, the ray of light which is traveling towards another optical medium, that is ray AN here in this case, is called as the incident ray. Now, the ray of light which deviates from its path and it enters into another optical medium, this ray is called as a refracted ray. So here the ray NM is the refracted ray. Why? Because ray NM has deviated from its path while entering into another optical medium. Whereas the ray of light which emerges out from the glass slab, that is MD, is called as the emergent ray. So which is the incident ray? Incident ray is AN. Which is a refracted ray NM, and which is the emergent ray MD. Now we have to be very careful when we use the terms reflected ray and refracted ray. A reflected ray is a ray which bounces back in the same medium, whereas refracted ray is a ray which enters into another optical medium. Okay, so be very careful while using the terms reflected ray and refracted ray. Fine. Now this is a normal and this normal is drawn at the point of incidence. What is the meaning of point of incidence? The point at which the incident ray meets the surface is called as the point of incidence. What is a normal? The normal is the perpendicular which is drawn to the surface at the point of incidence. So this is the normal. Okay. Now an angle is formed between the incident ray and the normal. Therefore this angle which is called as the angle of incidence. Similarly, this is the refracted ray, this is the normal, an angle is formed between the refracted ray and the normal, and this is called as the angle of refraction. Now in case of a glass slab, refraction of light takes place twice. Once when the ray of light travels from air into glass, and then when the ray of light travels from glass into air. Now let's consider the second refraction that is taking place. So the ray of light travels from glass into air. So what has happened once again? The ray of light has changed its path while traveling from glass into air. Now if we consider that in the second refraction that this is again an angle of incidence. So I am not going to write it as I because I is already referred here. So I will take it as I1. And this will be the angle of refraction here because this will be the refracted ray and this will be the normal. But here in this case, this angle of refraction is called as angle E, that is angle of emergence, because this is our emergent ray. Okay. Now angle I is always equal to angle E, that is angle of incidence is always equal to the angle of emergence. Now consider that there would have been no glass slab. Then had there been no glass slab, then what would have happened to the incident ray? Would the incident ray bend? No, that wouldn't have been possible, because in the absence of the glass slab there wouldn't have been change in medium. And what would have happened to the incident ray? The incident ray would have traveled straight without bending. So it is in the presence of the glass slab that the incident ray bends and the incident ray becomes parallel to the emergent ray. Isn't it? The incident ray is parallel to the emergent ray. Okay, so what do we see? We see that there is a shift in the path of incident ray. The path of incident ray shifted, isn't it? This would have been the path of incident ray, but what has happened because of the presence of the glass slab? The path of the incident ray has shifted. So this shift that we experience in the path of incident ray while it emerges from the glass slab is called as the lateral shift or lateral displacement. We call it as lateral shift, or we also call it as lateral displacement.